everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with the past paper questions of transformation of functions. So transformation of function is considered, and I think it's a reality, that it's one of the most trickiest and the difficult topic of T1. So let's give it due attention. Now, let me first revise. What exactly have we studied in translation? So if we talk about translation, there is a vertical translation, there is a horizontal translation. I'm just showing you the figures for right now, and I'll write down the information on a separate page. So just showing you so that your brain cells get all excited about this particular topic. And let me write on this particular page. And over here, let me write translation over here. So that's the first transformation. And I'm writing translation in the middle. And the translation could be parallel to x-axis. And the translation could be parallel to y-axis. So I'm writing everything very, very fresh. The concept is y is equals to f bracket x plus minus nh. And over here, parallel to y-axis, this is fx plus minus a k. Now let me choose the red marker. And over here, plus h, it means it will move h units to the left. Keep in mind, h itself is a positive value. So plus h means it will move h units to the left. And if I write, if there is a negative sign, so negative h means there is a shift. Let me also write a little bit more over here. So negative means h units movement to the right. And let me use the word shift or translation. I think I'll go with the word translation. So it's a translation of h units to the left. That means the translation vector will be negative h comma 0. It has a opposite effect. When we talk about negative h, it's a translation of h units to the right. And now the translation vector, TV stands for translation vector, that is h and 0. So that is what I have written over here. So that's about translation. Let me just shift this thing downstairs so that we can write very comfortably. And let me just remove this arrow. Let me remove this arrow. And let me just write this translation a little bit up. And let me move this thing over here. So parallel to x-axis, that is what's happening. Parallel to y-axis. Now over here, again, using the red marker, plus k. Plus means k units upwards. And negative k, it means k units downwards. So when we are moving k units upward, the translation vector is 0 and k. And when it's downwards, translation vector is 0 and negative k. Now, from the examiner's perspective, let me just write it a little bit spread out like this. So it's about shift or translation. So this shift or translation could be in this direction. And let me just copy this thing. And over here, this shift in translation could be upwards. All good, all clear? So now that is the first thing. Let me go to the other PDF and just have a look over here. Sketch the graph of each of these functions. Y is equals to fx plus 2. Now there are three major points. The transformation is all dependent on these 3 points. If you move them, the whole graph will get shifted. So if A is 0, 1, the red color one, that is movement of 2 units up. The x coordinate remains the same. Y coordinate gets increased by 2. What about the blue one? That is f bracket x minus 1. This is a horizontal shift. Over here, negative means right. That means the point A01, this, the horizontal value, that is the x-axis, that gets increased by 1. The y-coordinate remains the same. And this is a combination of these two, except that this is plus 2, this is minus 2. So first, plus 1, that means go 1 unit to the left and 2 units down. Go 1 unit to the left and 2 units down. So first of all, over here, if I focus on this, the final answer is 2 units down and 1 unit to the left. That is just a basic idea of translation. That's how the graph looks like. This is fx plus 2. The whole graph is shifted upwards. F bracket x minus 1. This moves here. This moves here. This moves here. And over here, what is happening? It's moving 1 unit to the left and it's moving downwards. So this one is over here. This one is over here. This one is over here, 2 units down. So that is the idea of translation. So now let me write it in the group. That translation, if it's all good, all clear. So the concept of translation, first we have to revise our basics and then we can move ahead. So now this thing is done. Let me move to the next thing, which should be about stretch. Okay. And reflection. Now for reflection, when we are talking about reflection, there are 2 kinds of reflection. There is reflection in the x-axis. There is reflection in the y-axis. Which one is which? Let me write on that particular page. So over here, let me add a page for reflection. So over here, I'm talking about reflection and I can write it sidewards. So this is REFLECTION. It's not a permutation combination question. It's about reflection. The first thing, it's about reflection in y-axis, or actually we are writing all the x to the left. So let me write it like this. Reflection in x-axis. And then over here, it's reflection in y-axis. When something is reflected in the x-axis, a point such as AB, the x-coordinate will remain the same, y-coordinate changes sign. When something is reflected in the y-axis, AB, the x-coordinate changes sign, y-coordinate remains as it is. What about the transformation? Y is equals to fx will become y is equals to negative of fx. So this negative over here, that corresponds to reflection in x-axis. And over here, y is equals to fx becomes y is equals to f of negative x. This negative over here, that corresponds to reflection in y-axis. Now on the next PDF, let's have a look. This is the graph of y is equals to 2 raised to power of x. This is an exponential graph, a power graph. Now, if I have a negative on the outside, this one is reflection in x-axis. So this will be like this. This 0, 1 will become 0, negative 1. And what about when there is a negative on the inside? The graph will look like this. So this 0, 1 will remain as 0, 1 because it's on the mirror line, and this is reflection in y-axis. Let's have a look. So now this is 2 raised to power of negative x. That is reflection in y-axis. Reflection in x-axis, that is like this. That is what you have to focus on. So reflection is all good, all clear. Again, let me add a page. So now I'm writing over here the third transformation. And which one is that? This one is stretch. Now stretch could be along x-axis. Stretch could be along y-axis. And let me first write the rule and then the equation. When the stretch is along x-axis, a point such as AB will be changed to something else. And let me write over here. This AB will be changed to A multiplying with 1 over K comma B. And when the stretch is along y-axis, AB will be changed to something else. And what will happen over here? The y coordinate will be multiplied with K, where K is the scale factor. So now over here, let's focus on one word, and that word is multiplication. So now the rule is whatever is the multiplication factor, I'll call that as the stretch factor. In this case, the x coordinate is multiplying with 1 over k. X coordinate is multiplying with 1 over k. Therefore, the stretch factor SF is 1 over k. Over here, when the stretch is along y-axis, what will happen? The y coordinate is multiplied by k, and let me change the color because I'm just working in blue color for this thing. So let me change it to blue. So over here, this scale factor, stretch factor, this is k. Now, how will the equation look like? Y is equals to f of something x. We will write over here a. If a is written, I think, let me just write a k over here. If k is written, that means the stretch factor, the scale factor is 1 over k. Over here, I'll write y is equals to something fx, and let me write a k on the outside. So let's analyze this in very much detail. We are talking about stretch. It could be along x-axis, it could be along y-axis. A point AB will become A multiplying with 1 over k. This 1 over k is the stretch factor, the scale factor, the multiplication factor. Now over here, how will the equation look like? F of kx, the stretch factor would be the reciprocal. The x coordinate is multiplied with 1 over k. Let's stick with the word multiplication. We won't use the word division. So as to avoid confusion, multiplication, that is what we are focusing on. If it's a k written over here, the x coordinate is multiplied with 1 over k. Whatever is the multiplication factor, that is the stretch factor. When the stretch is along y-axis, a point AB will become A, KB. Y coordinate is multiplied by k, and the stretch factor is k, and this k is written on the outside. This k is the coefficient of x. Let me re-emphasize the same thing using this. You can transform the equation of a function fx by simple stretches of these forms. So there are two formats. First of all, let me choose a red color from here, and we are multiplying the x coordinate by 1 over a instead of k. They have written a, that doesn't make a difference. And this is f of ax. Whatever is the coefficient of x, the multiplication factor, the stretch factor, let me write it over here. Stretch factor is 1 over a or 1 over k, where a is the coefficient of x. So a is the coefficient of x when we are talking about a horizontal stretch. All good, all clear? So now when I'm talking about a vertical stretch of scale factor a. So you multiply the y coordinate by a and leave the x coordinate unchanged. This is a of fx. Let me also highlight over here using the red marker. So let me choose the red color over here. It's a horizontal stretch. Scale factor is 1 over a. That is written just like this over here. All good, all clear? So now AFX, it's a vertical stretch of scale factor A. Multiply the y coordinates by this, and you are only multiplying the y coordinate, therefore x coordinate remains unchanged. Similarly, over here, the y coordinates remain unchanged. It's exactly the same thing that I have written over here. So now if this is all good and all clear, since it's the most tricky one, therefore we need to focus a bit more on this. First of all, they are asking us, given that it's an exam type question, let me label it. So exam type question, given that fx is 9 minus x square, which can be written as factorization 3 square minus x square, which can be written as 3 plus x and 3 minus x. Sketch the curve with the equation y is equals to f of 2x and y is equals to 2fx. First of all, let me write it. F of 2x, the coefficient of x is changed. Therefore, it's a horizontal stretch. That is the first thing. Second thing, I can write it's along x-axis. That is what horizontal means. And this is like f of ax, therefore the scale factor, the stretch factor is 1 over a. Over here, the 2 is on the outside. That means it's a vertical stretch. And if it's a vertical stretch, it is along y-axis. It is k of fx or a of fx. And the stretch factor is what's written over here, that is a. Over here, the hint is, remember the word reciprocal. Also, let me write over here, the 2 is on the inside. So now let me just erase this thing. Now everything is set over here. Now when we are talking about 3 plus x, 3 minus x, if I want to sketch it, so the sketch will be a quadratic which is upside down. Why is it upside down? Because the coefficient of x square is negative. I can also sketch it like this. Fx is negative x square plus 9. Draw negative x square like this. Let me draw it a bit better and then shift it up by 9 units. That's one way of drawing. The other way is the factorized form. So the coefficient of x square is negative, it's upside down, and the roots are, this is negative 3, this is positive 3. And if I draw the y coordinate, it's not drawn to scale, it's just a rough sketch. So this y-intercept, not the y coordinate, the y-intercept is 9. Now what are we interested in? We are interested in a horizontal stretch. So therefore the x coordinates should be multiplied with 1 over a. So f of 2x, a point such as negative 3, 0, a point such as 3, 0, a point such as 0, 9. What will happen? the stretch factor is 1 over 2 because 2 is written over here. So this will become negative 3 over 2 comma 0. This will become 3 over 2 comma 0. This will become 0 into 1 over 2, that is unchanged, comma 9. And if we are talking about the same coordinates, negative 3 0, 3 0, 0 9. And now this is 2 of fx. The stretch factor is 2. It's applicable on the y coordinate. So let me just focus. It's applicable on x, it's applicable on x, it's applicable on x. 0 remains unchanged. And over here, it's applicable on y, it's applicable on y, it's applicable on y. So therefore, what will happen? The 0 will remain unchanged, the 0 will remain unchanged. This 9 will be multiplied by 2. So therefore, this will become 18. So this is negative 3 0, this is 3 0, and this is 0 comma 80. So basically, what will happen, and I have the diagrams drawn for you. This one will kind of shrink like this. It would be squeezed inside. And over here, what will happen? The two roots will remain the same and it will be cutting at 18. Now let's have a good look at it. That is the original graph. That is which one? It's squeezed. 3 becomes, negative 3 becomes negative 1.5. 3 becomes positive 1.5. So therefore, let me write y is equals to fx. And this is y is equals to f of 2x. This is a horizontal stretch. I'm re-emphasizing it over and over again. It's a horizontal stretch. Y coordinate unchanged. And this, first of all, scale factor is half. And what should I write more? The x coordinates are multiplied by 1 over 2. So negative 3 becomes negative 3 over 2. Positive 3 becomes positive 3 over 2. And that is what is obvious over here. That's how the change occurred. Let me write the same thing for these two. What do you observe? This is y is equals to fx. This is y is equals to 2 of fx. And now let me write, it's a vertical stretch. And if it's a vertical stretch, first of all, I should write which one remains unchanged. The x coordinate remains unchanged. Now, when the x coordinate remains unchanged, as you can see, what changes? The y coordinate is multiplied by scale factor, which in this case is what? That is 2. Let me grab this thing back. This is scale factor is 2. That's right over here. So therefore, 9 becomes 18. Therefore, 9 becomes 18. So it is stretched along y-axis. It is stretched along y-axis. This is stretched inwards towards x-axis. That is the bottom line of the story. Let me further re-emphasize it using trigonometry. So let me write over here, the graph of y is equals to sine x. This is 0, this is 180, this is 360. And the maximum occurs at 90. What is the maximum value? That is 1. So I'm focusing on the maximum, that is 90 degrees, comma 1. This is y, this is x. Of course, you can label it. Now, which graph is this? This is 1, this is 2, this is still 90. And this is 180, this is 0, this is 360. The number of cycles remain the same. But now, if this is y is equals to sine x, this is y is equals to 2 sine x. It's a vertical stretch. If it's a vertical stretch, that means the scale factor is 2 and y coordinate is multiplied by 2. X coordinate remains unchanged. So therefore, 90 comma 2, this point was 90 comma 1. So 1 becomes 2 because of the scale factor multiplication. All good, all clear? Let me further emphasize it. Now over here, what have I drawn? I have again drawn y is equals to sine x. This is 0, this is 180, this is 360, and this one is 90 degree corresponding to 1. And over here, what have I drawn? I have drawn y is equals to sine of 2x. What is the rule? That is 2 cycles in 360 degrees. That's the rule. Therefore, in 180 degrees, we are drawing one cycle. So this is 0, this is 90, this is 180. Half of 90 is 45. That means at 45 degrees, we are getting 1. Now this point over here, 90 degree, comma 1. This point over here, 45 degree, comma 1. This is the maximum. This is the maximum. That means 90 degree, comma 1. The original thing, it has changed. So now how has it changed? 90 degrees is becoming 45. Why? Because if 2 is written over here, scale factor is half. So therefore 90 degrees into half is giving me 45. This makes perfect sense. Similarly, let me draw over here y is equals to sine of half x. This is 0, and even before that, half cycle in 360 degrees. That's the rule. Therefore, a full cycle in 720 degrees. So this is 720. This is 360. Between 0 and 360 is 180, and this is 1 over here. That means the maximum point 90, 1 is now becoming 180, 1. What is written over here? Half. Therefore, the scale factor is the reciprocal of half, which is 2. So therefore, 90 degrees is multiplied by the scale factor. It's giving me 180. It has the opposite effect. So all good, all clear from stretch. Now it's time that we can start with the transformation past paper questions. Transformation belongs to the functions category. The last statement is about transformation. Let me highlight it for you. Understand and use the transformation of the graph of y is equals to fx given by y is equals to fx plus a, y is equals to f of bracket x plus a, y is equals to a of fx, y is equals to f of ax, and a simple combination of these. Which one did the examiner miss out? These two are translation. This is vertical translation and this is horizontal translation. This is stretch along y-axis. This is stretch along x-axis. They missed out reflection, but then they covered it up over here. So basically they should have written it like this. If I were the examiner, I would write it like this. Y is equals to fx plus minus a k. That is how I explained it. Y is equals to f bracket x plus minus h. That is horizontal translation. Y is equals to a of fx. Y is equals to f of ax. These two are stretch. These two are translation, vertical and horizontal. And I should also write y is equals to negative f of x. That is reflection in x-axis. Reflection in x-axis. And y is equals to f of negative x. This is reflection in y-axis. So these two were missed out by the examiner. So these two were missed out. I have focused on it. Yes, they did cover it up over here, include use of the term translation, reflection. Now over here it's reflection, but they have not shown on the left hand side. And stretch in describing transformation, questions may involve algebraic or trig function or other graphs with given features. So now let's look at this first question. It says the graph of y is equals to fx is transformed to the graph of this thing. Describe fully two single transformations which have been combined to give the resulting transformation. Now remember a word or an equation that I'm writing. I'm writing inside and then I'm writing outside. Or I think it sounds more classy, inside out. So first focus on the function. Whatever is immediately written with the function and then grow outwards. So basically what is happening is that fx will be transformed to f of half x. It will be transformed into f of half x plus 1. It's better written as y is equals to f of half x plus 1, because unless and until you have a function, what will you do with the vertical translation? So write in the proper format. Now, first thing first, which is this one? This is a stretch. It's a horizontal stretch. You can further write it as along x-axis. The coefficient is half in the horizontal stretch. The scale factor is the opposite, which is 2. The stretch factor, scale factor, multiplication factor. And what is this? This one, the one on the outside, it's a vertical translation of 1 unit up. You should also write the translation vector, which is 0, 1. Is that all that they're asking? Yes. They're asking describe fully 2 single transformation which have been combined to give the resulting transformation. 4 marks, that means 2 marks for each. 1 mark for horizontal stretch, 1 mark for the scale factor, 1 mark for the vertical translation, 1 mark for the translation vector. Let's check the mark scheme. That is this: stretch factor 2, x direction, y-axis invariant. Just ignore this thing. So this one is more than enough. It's a stretch factor 2, x direction or horizontal. And then translation, I'll skip the word shift. 1 unit in y direction or upwards. That makes sense. And the translation vector, which is 0, 1. So that's how the first question is done and dusted. Let's move on. Next question. Now over here it says in each of the parts A, B, and C, the graph shown with solid lines has equation y is equals to fx. So this is y is equals to fx. This one is y is equals to fx. This one is y is equals to fx. The graph shown with broken line is a transformation of y is equals to fx. The first part A, state in terms of f the equation of the graph shown with broken lines. Now, what do you observe? We observe that this is a reflection in this particular line, which is the y-axis. How can we observe it? This point becomes this point becomes this point becomes this. So it's a reflection in y-axis. They are asking us state in terms of f the equation of the graph with the broken line, naturally in terms of this thing. So we will write y is equals to f of minus x. Why? Because this is a reflection in y-axis. They're not asking us to explain it. They are asking us to simply write it. We can only write it provided we have understood the concept in and out. Now, this thing is all good, all done. Now over here, state in terms of f the equation of the graph shown with broken lines. Now, let's say the horizontal difference was 2. The horizontal difference like this is still 2. Let me select few points and that will give me a good idea. So let me select this point, which is 2, 1, and it's becoming 2, 2. So 2, 1 is becoming 2, 2. Let me select this point and this point. So 1, 2 is 1, 4. 1, 2 is 1, 4. I think it is very obvious by now what exactly it is. So now this is a stretch parallel to y-axis and the scale factor is 2. Because the y coordinates are multiplying by 2. 1 is becoming 2, 2 is becoming 4, and over here, this 3 is becoming 6. So it's a stretch parallel to y-axis, scale factor 2. Therefore, we will write y is equals to 2fx. That is how this will be written. All good, all clear? Let's move on to the third one. Now it says in part C, the equation of the graph shown with broken lines. Now we know that this is like 1 unit this way, 1 unit this way, and then like 2 units and 1 like this, 2, 1 like this. So that means the shape is not distorted. The shape is not distorted. Therefore, it's a translation. And it's not one single translation, it's two translation. First of all, from this point onwards, that is 1 and then 2 and then 3. And we are talking about over here and then 4. So it's 4 units left. And then we are talking about going 1 unit down, 2 unit down, 3 unit down. So this is going 3 units down. That means the translation vector is -4, -3. And they're not asking for the translation vector. They are asking for the equation. So therefore, y is equals to f bracket and then something. This 3 down over here, it's -3. X should be over here. If it's going to the left, that means there should be a +4 over here. So f bracket x plus 4 minus 3, that is what is happening in this question. And let's just double check this thing. So f of minus x, 2 of fx, f of x plus 4 minus 3, that is the answer. So I hope it's all good, all clear. So now, so far, so good. Yes, everyone. Is it all good, all clear? AS1 and AS2 and the other people. Okay. Now, let's look at this question. Now we see a quadratic over here. Read the question first. And let me pause the recording. I want you to try it out. It's not that difficult. So let me just pause the recording over here, and that is the recording is paused. So now the very first thing that is being asked over here, that is express this thing in the completed square form. Remember, the original standard for the completed square form is ax minus h whole square plus k. It's just giving you an idea, a hint that change it into the completed square form. So first thing first, that is make sure coefficient of x square is 1, which is the case. First add, then subtract square of half the coefficient of x, which is 3. Rewrite the first 3 terms as a perfect square, which is x plus 3 whole square. This is, don't forget the square. This is -9 plus 5, which is -4. That is what is happening. Now, if I write underneath it, a x minus h whole square plus k. So a is 1. That means the graph has a shape like this. H is -3, k is -4. Therefore, -3, -4, that's the coordinate of the turning point. That's extra information that I've written over here. Now the next part. The curve with the equation y is equals to x square is transformed to the curve with this particular equation. That's right over here. Describe fully the translation involved. Now, when we talk about y is equals to x square, getting transformed to y is equals to x plus 3 whole square minus 4, there are 2 ways of stating the truth. The first way is that the turning point of y is equals to x square is the origin. The turning point of this new curve is -3, -4. So now the first thing that you can say is this thing, that what is happening? Translate 3 units left. and 4 units down, because this 0 is becoming -3, this 0 is becoming -4. Therefore, the translation vector is -3, -4. That's one way of stating the truth. Another way is we are focusing like this. That means this graph over here is the original one, plus means 3 units to the left, and -4 means 4 units down. So this is like this. This is f x plus 3 whole square minus 4. That is f bracket x plus h whole square minus k. So we know that a plus means h units left. So this h in this case is 3. That is 3 units left. And over here, k with a negative sign, that is 4 with a negative sign, that is k units down. So therefore, this is 4 units down. And the translation vector has a 4 with a negative sign, has a 3 with a negative sign, and that is the translation vector right over here. So there are 2 ways of explaining the truth. All good, all clear? So now it's over here. Completing square, translation or shift. So now this is -3, -4, and that is what you have to write. And did it use the word describe? Describe fully the transformation. That is how the description would be. Along with the translation vector, you should not skip this thing. Now, another question of the same type. Well, this is very similar to the one that we did. So let's skip this and let's focus on this thing. So now another question in which the description is there and the equation of the curve is there. So there are 2 ways of asking this question. The graph of fx is transformed to the graph of this thing, which is over here. Hold for a second. Is transformed to the graph of this thing. Describe fully 2 single transformation which have been combined to give the resulting transformation. So this is one question. The other question, the curve y is equals to sine 2x minus 5x. It's reflected in the y-axis, and then they're describing the order stretched by a scale factor of 1/3 in the x direction. Write down the equation of the transformed curve. So let me share this with you, and so that you can try this particular page out. So there are 2 things over here. One is about description, one is about the equation. So let me just pause the recording. So now people, let's look at this question. First of all, the stretch thing that needs to be emphasized a bit more. If I talk about this thing in general for any curve y is equals to fx and any value of a greater than 0, y is equals to afx is obtained from y is equals to fx by a stretch of scale factor a parallel to y-axis. So first of all, let me highlight this. There is an a on the outside. This is a stretch. This is parallel to y-axis and the scale factor is a. But if we are talking about a stretch and it's parallel to x-axis and the scale factor is a, it will be written as f of x over a. And over here, if there is a stretch of scale factor 1 over a, it will be written as f of ax. It's a reciprocal thing. What I mean to say is this thing, that we are talking about f of 2x. Then in this case, scale factor is 1 over 2 because the coefficient over here is like a. If it's f of half x, Then the coefficient over here is half, that is a. Therefore, the scale factor is 1 over half, which comes out to be 2. It's the opposite. Yes, we know that the x coordinate is multiplied by 1 over a, or we can say it's divided by a. Let's stick with multiplication. So now, why do I need this? I need it for the second part. So let me solve the second part first. So the second part says, the curve y is equals to sine 2x minus 5x is reflected in y-axis. So y is equals to, if x is becoming y is equals to f of negative x. This is reflection in y-axis. So now if I reflect this line, y is equals to sine 2x minus 5x, or I can write fx is equals to sine 2x minus 5x. So wherever there is x, it needs to be replaced with negative x. So therefore, f of negative x, that is sine of negative 2x minus 5 of negative 2x, negative x, not 2x, it's x over here. Therefore, this will become what? This is sine of negative x is the same thing as negative sine x. So negative sine 2x, this minus becomes a plus, that is 5x. Now, which property have I used? Sine of negative theta is negative sine theta. So I have used this thing over here. This minus is coming on the outside. That is reflection in y-axis. That's the first thing. Then it says, it is then stretched by a scale factor of 1/3 in x direction. So now, if the scale factor is 1/3 along x-axis in x direction, that means the value of a is 3. 1/3, the reciprocal is 3. The scale factor is 1 over a. So therefore, this 2 goes over here. If it was the scale factor was 2, we would write half over here. Currently, it's 1/3. So therefore, a is equals to 3. So now in the red color thing, f of negative x is negative sine 2x plus 5x. What will I do? I'll replace, this thing is already there. Okay. So let me just replace this thing. This thing is already there. Wherever there is x, wherever there is x, wherever there is x, I'll write 3 over there. So therefore, this is negative sine 2 into 3x, because x is replaced by 3x. So that's 2 into 3x. And this is 5 into 3x. So this is negative sine 6x plus 15x. That is the equation of the resultant curve. So that was the tricky part. The second part. Let's first have a good look at it. Sine of negative theta minus sine theta. And over here, reflection in y-axis. So this minus is there, this minus is there, this 2 become positive, this minus comes out according to this rule. And then scale factor is 1/3. So a goes over here. X coordinate multiplies with 1 over a. This whole thing is the scale factor, but we write a over here, the reciprocal. And then the final answer is minus sine 6x plus 15x. That is the answer for this part. Also, double check the mark scheme. They have also written sine of minus 6x. I have written minus sine 6x. 15x, 15x right over here. Now we are left with the first part. Let's focus on the first part also. So let me add a page over here. And this first part, that was straightforward. That is this thing. The graph of y is equals to fx is transformed to y is equals to 2fx minus 1. Describe fully 2 single transformation which have been combined to give the resulting transformation. So now for part A, what do? We know that y is equals to fx inside out. that would first become f bracket x minus 1. That would then become 2f bracket x minus 1. It's inside out. So now the first thing is this thing, fx is x minus 1. What is that? This is a translation. And this translation is parallel to x-axis. And what else is there? There is -1. That means 1 unit to the right. And we can write the translation vector as 1, 0. That is the blue thing. What about the green thing? This 2 over here. And then there is a stretch parallel to y-axis. And whatever is written, that is the scale factor. K comes out to be 2. That's right over here. All good, all clear? Let's double check this thing. That is translation of 1, 0. Let me just erase all this thing so you can have a good look. Translation of 1, 0, stretch factor 2 in y direction. All good, all clear. Now, another question over here, and I would like you to try it out. So let me just pause the recording. So now let's have a look at this. It says function f and g are both defined for x as an element of real numbers and are given by fx as this and gx as this. By first expressing fx and gx in completed square form, express gx in the form where f bracket x plus p plus q. That means how is x transformed to this thing? Okay. So now, first of all, and then it says describe fully the transformation which maps fx onto gx. That's what the whole purpose of this thing is. So now I think I have the solution. Fx is x minus 1 whole square plus 4 and gx is x plus 2 whole square plus 9. So let me write over here. Fx is x minus 1 whole square plus 4. And gx is x plus 2 whole square plus 9. This is x plus 2 whole square plus 9. Now let me write underneath it a x minus h whole square plus k. Let me write underneath it a x minus h whole square plus k. Now a is positive in both. A is 1. So let's ignore a. Minus h is minus 1. Therefore, h is 1. K is 4. 1 comma 4, that's the coordinate of the turning point. So 1 comma 4, that's the coordinate of the turning point. H is -2. K is positive 9. Therefore, minus 2 comma 9, that's the coordinate of the turning point. Now, what's happening to the turning point? If I focus on the x coordinate, 1 is becoming -2. So 1 is transformed to -2. If I focus on the y coordinate, 4 is converted to 9. That means there is a movement of 3 units to the left. The difference between 1 and -2 is 3 units. It's negative. That is why I'm saying it's moving to the left. And 4 till 9, that is 5 units upwards. That means the translation vector is -3 and +5. That is the translation vector. Now they are asking us, first of all, I think I have answered part B first. Describe fully the transformation which transforms the graph fx to the graph of gx. So fx is moved 3 units to the left. And order as such does not make a difference over here. You could move left and then up, or first up and then left. It doesn't make a difference. And 5 units upwards. And the translation vector is right over here. And what about the equation? The equation can be like this. So f bracket x something and then something. So it's 3 units to the left. So write a +3. which means 3 units to the left and 5 up. Now let's double check the result. So the result is right over here. Let me get the eraser ready. That's over here. First of all, this is fx, this is gx, and I answered this thing first, translation, and then I answered this based upon the turning point f bracket x plus 3 plus 5, f bracket x plus 3 plus 5. That's the answer of part A, and this is the answer of part B. So I think that's enough practice. Well, it's never, you can't say it's ever enough, but that's a lot of practice of P1, transformation of functions, transformation of graphs, which is one of the most important topic of functions. So stay tuned for more content from Mathematics with Shahab Yaqub.